Assalamualaikum warahmatullahi wabarakatuh. So basically we already in week 4. So for this week I will touch on the valve. Okay, so basically this is the same example like before, which is the flow control system. So we have first a measurement by sensor. In this figure we have this one is a transmitter, the flow transmitter, and then the signal is sent to the controller, and next the signal is sent to the transducer. Lastly, transducer will convert the signal into pneumatic signal to the control valve. So basically this is the basic process control loop you need to remember. Okay, so for this the content for this topic, okay, first we will learn about the selection of action, field position, capacity and sizing, flow characteristic, gain, transfer function, and type of valve. Okay, so now let's have a look. Okay, basically valve is the one that take an action in the control loop system. Okay, so basically valve, the control valve is one of the example for the final control element, the most commonly used inside the industry. So basically the control valve will adjust the flow that affect the control variable. It will act as a variable restriction in a process pipe, and also the control valve will receive a signal from the controller. Basically the controller will send the controller output signal to the valve. So the valve will change the positions of the valve based on the signal that been given by the controller. So basically the output signal from the controller is the input to the valve, and the flow is the output of the valve. So basically after the valve receive the signal from the controller, that valve need to adjust the position of the valve, so at the same time cause the flow of the pipe that flow through the valve to change. So that's why the flow is the output of the valve. Okay, so now, and this is the figure of the control valve. So the purpose for the control valve is to regulate flow of any phase. For example, like liquid, gas, fluid, and mixed phases. So, but for the solid phase, it is impossible for the valve to regulate the flow because of the texture or the content of the solid phase itself. Okay, this control valve is commonly used inside the chemical industry. Like 80% of final control elements inside the chemical process industry. So this is the figure of the control valve, and this is the symbols that need to use when you want to draw the PNID. Okay, basically the construction of the valve consists of actuator and also body. So for the actuator, we have here is a supply air connection, upper chamber, lower chamber, spring. We also have a diaphragm and also housing. At the body side, we have a stem. So that stem will move according to the movement of the spring inside the actuator. The movement of the spring is based on the supply air that enter the actuator head inside here at the upper chamber. Okay, when the valve is closed, that means the seat will close this hole, cause the flow, cause the restriction to the flow. Okay, So this is the symbols of the control valve. Okay, we have two types, which is detailed one and also conceptual simplification. Okay, so this one you can see that the signal from controller is in the electrical signal because of the dash line, and then there's a transducer, which is this one is a transducer. This transducer will convert the electrical signal to the pneumatic signal. Okay, we can see the units in here is PSIG, which is referring to the pressure pneumatic signal, and then from the input from the controller, the valve will change the positions in order to allow or not allow the fluid pass through the valve. So basically, the air pressure actuator is the most common to adjust the position of control valve. So normally, control valve, the movement, like what I'm saying inside the previous slide, the movement of the valve itself is based on the air pressure. Okay, so next is the controller signals. Inside here normally is in percentage or in a milliampere. Okay, so for example, like you have a percentage, you will the transducer will convert the value into the valve positions. The valve positions can read the pneumatic signal. So the valve position usually expressed as a fraction, varies between 0 and unity. So basically from 0 to 100% lah for the valve positions. Okay, when the valve position is 0, the valve is closed and the flow is 0. That means there is no flow pass through the valve. When the valve is unity, the valve is fully open and the flow is maximum. So for full range valve actuator, 1% change in the controller output result in 0.01 change in the fraction of valve position. So the most common control valve is a full range actuator. Okay, now I will explain about the control valve actions. So we have two types of control valve actions. So okay, what do I want to do when energy supply fails? Okay, so when the energy supply fails, sometimes it may cause the consequence on the equipment. For example, the equipment that perform heating process, there is a steam flow inside the equipment. So when the energy supply fail, the flow of steam may be cut off, so there is no energy can be supplied to the heat exchanger, for example. So what do we gonna do when energy supply fail? Okay, so now I will explain that relate to the failure of the energy supply. So when the safest position of the valve is the closed positions, okay, we have two types. We have a closed position and also open position for the control valve action. Okay, the first one is the safest position when the valve is in a closed position. So that why we call it as a fail close. That means when there is when the energy supply is fail, the valve act as a fail close. That means it will close the flow. So there is no steam. For example, like the previous example, there is no steam will be entered to the system. So this valve basically require energy to open, and we also call it as a air to open. Okay, so like what I mentioned before, normally we will use air pressure to operate the valve. So for this one, we need air to open the valve. When the energy supply is fail, then there is no air supply. So the valve become fail closed. the valve will not open, it will close. So the next position is open positions. That means when the energy supply fail, that valve will open, fully open. This type of valve require energy to close, and it also call it as a air to close. That means you need the air pressure to close the valve. So when there is no energy supply, so the air pressure cannot be supplied. So that valve will fully open until the energy supply is restored back. Okay, so now I will explain about the selection criteria between those two type of valve, which is fail open, also known as a ATC, fail close, also known as a ATO. So basically, we compare first the structure of each of the each of the valve. Okay, so here is a air to close. So we can see the air inlet is from above. That means to operate this valve, we need to supply the air from above, from here, and then that air will push the spring down and cause the steam, this one, to go down, and this seat will close the hole. So that's the way the air to close valve operate. But when there is no energy supply, there is no air that can be fed into the valve, and this valve will remain open like this. Okay, comparing with the air to open or fail close valve, we can see here the air inlet at the lower chamber here, in here. So basically, this valve, for the valve to operate, we need to supply the air, and that air will push the spring up, this spring up. So when it push the spring up, the stem will increase also. So the seat will increase, cause the hole to open and cause flow through the valve. Okay, if the energy supply is cut off, there is no air can be fed into the valve, so this valve will remain at this position, which is fully closed. Okay, so the other difference of this ATO and ATC is the screw, the spindle screw, the direction of the spindle screw here. One at the downward positions, the other one is upward position. So based on the air inlet. Same goes to this part. The level. One at the top level, the other one at the below level, bottom level. Okay, so now we have one complete control system for the rector. So basically, this rector is installed with the heating coil. So this heating coil, the feed is a steam. So basically, we have a flow control system, pressure control system, and also level control system. Okay, right now we see one by one which type of valve that been used for each of control system. Okay, so for example, like if the electrical or air supply fail, so that's mean, okay, for the flow control system, okay, when the air supply is failed, logically we don't want the steam, the excessive amount of steam entering the heating coil, right? the excessive amount of steam will cause the fluid, the mixture inside this tank to increase, the temperature of the fluid inside this tank to increase or overpressure. So that's why we use the fail close valve, because if there is a energy supply cut off, the steam feed directly cut off. We want to prevent high steam flow that could vaporize all the liquid and overheat the coil. For the second type, which is the level control system, okay, so for this one, okay, basically if the energy supply is cut off, okay, logically we don't want all the mixture of fluid inside the tank to leave the tank. If the liquid or mixture inside the tank leave the tank without any restriction, it causes the tank to the level of the tank to decrease. So the tank will dry. So we need to use the fail close valve in order to overcome the energy supply cut off issue. When we use the fail close valve, when the energy supply is cut off, this valve will directly close and it will contain or keep all the liquid inside the tank without releasing all the liquid. So there is no dryness issue or the overflow issue also, to overcome the overflow issue. Okay, next is a fail open. Next is a pressure control system. So for the pressure control system, normally we'll use fail open. Why? Because when the system is tripped or the electrical supply or air supply is failed, normally the feed inside, the mixture inside this tank will vaporize, right? If we use the fail close valve in here, the vapor will accumulate inside the system and cause the tank to be over pressure, and lastly it can cause an explosion. So that's why we use the fail open valve at the pressure system, so that when the electrical or air supply is failed, all the vapor from this tank can vaporize and go out from the stream. It will not accumulate inside the tank. Okay. Now I will explain about the action of the valve determine the sign of the gain of the valve. So basically, for the air to open valve, which is ATO, has a positive gain, while for the air to close valve has a negative gain. Okay, we can use this formula to calculate the valve position to the controller output. So basically we have a M bar here for the controller output. So for the ATO valve, M bar is is divided with 100. For the ATC, to calculate the valve position, you need to minus 100 with M bar and over 100. Okay, now I will explain on the exercise. Okay, basically we want to determine the valve position for the ATO system and ATC system. So given in here is 10 PSIG signal from the controller. Okay, so we use the formula ATO is equal to VP, the valve position for ATO is equal to VP the controller output, which is 10 over 100. Then you can get 0.1. For the ATC, the VP 100 minus with 10 over 100. So this one is 0.9. Okay. So this is the end of the slide. I will continue on the next slide, which is slide 4B. Thank you.